and it is the 25th of October 2004, and we're at Chuck's house in Arvada. So to get started, Chuck, I was hoping you could just tell me a little bit about your background, where you were born, where you grew up, what your parents did.
Okay. I was born in Denver, so naturally I wanted to stay in Denver. I went through grade school and school in Denver, graduated East High School, and after graduation I enrolled at CU Boulder and got a degree in mechanical engineering. Was in Theta Xi fraternity, which is no big deal. But at the end of school, I interviewed with all the people that were looking for engineers at that time. I must have had choice of 10 or 15 different places I could travel to, and ended up working at Carbide and Carbon Chemicals, Union Carbide, in South Charleston, West Virginia. Really the pits compared to Denver. So I worked there a year. Pardon?
What year was this?
That was 1952.
So you were born in
29.
Okay.
And I'm and absolutely probably. Carbide Carbon, I was one of their engineers. Worked with gas line feed for a rock product for the chemical company. And came to visit me in Christmas of that year, that she wasn't going to be able to work. They interviewed her and said, well, with your degree from the University of Colorado, you'll have to have a year of West Virginia history before you could go to work in the West Virginia schools. So she decided she didn't want to do that. And West Virginia isn't all that great anyway. So I came back in May of 1953 for her graduation and started looking for a different job, and went down to the draft board to let them know that I was in Denver now. I'd changed my address, and they walked in the door, and the lady says, "Oh yes, Mr. Bogard, we have your file right here." Uh-huh. So I spent the next 2 years after July of 53 in the Army, and was in the Scientific and Professional Personnel Corps. Oh, incidentally, I did get married in June of 1953. So went into the Army, went to basic training at Fort Knox, Kentucky, and my wife joined me when we went to for my permanent assignment at Edgewood Arsenal in north of Baltimore. So we were right near the ocean, Chesapeake Bay, and that's a big change for a Colorado boy. So we stayed there 2 years, and I worked, the Army put me to designing, not designing, drafting for nerve gas bombs. Well, it would have been nerve gas, but war gas bombs, bomblets. And I was just a draftsman. We had PhD doctors that had been drafted too, and they were doing laboratory analysis. The Army doesn't know how to use a private, especially one with an education. Anyway, after when I was about to get out of the Army, I was able to interview several of the companies that wanted engineers that had served their draft time and a master's degree or bachelor's degree, so that was great for them. And the Army provided them facilities so that they could interview. So I interviewed several companies, and finally a Rocky Flats representative came there, and I was able to interview, and I was very interested in that because it was reasonable salary and in my home. So I took the job with them, and at that time they had no way for a person without a Q clearance to work inside the plant. No way. So they had me work with a company that was doing some surveying for the building 447 was what it turned out to be, addition onto building 44. And I helped them survey, got my first impressions of Rocky Flats. You couldn't drive a nail into the soil without hitting a rock, and that's the way it is still. And worked with that surveying company in various places that they had jobs for 3 months while my clearance was being handled. I think the clearance took a total of 4 months, and in later times it took even longer. But as soon as I got my clearance, I worked in building 111 now. Was 111. It's gone now. And in 111, that was the executive building to the management building, and engineering had a good-sized office there. Engineering and purchasing both. We were right across the hall from each other. So I worked there for about 9 months maybe, and then they needed some engineers down in building 991 for work with the what did they call it? The design group for the weapons people. And at that time it was only a group of about 12 or 13 people.
So what were you doing in building 111? What kind of engineering work?
That was design engineering and plant engineering also.
So designing buildings and
Yeah, the engineering group always supervised any outside contractor building a new addition to the plant or things like that. At that time, there were no additions to the plant other than what the Austin company, who were the original designers of the plant, had already made the plans for. This building 447, they had the complete drawings before Austin ever left. So, and when Austin left, of course, we took some of their engineers, and so there was a lot of continuity there. My engineering boss at that time had worked on the Manhattan project in New Mexico, and my big boss in engineering was out of the Dow Engineering division up in Michigan, and he was about 35, I think, at that time, and we were a fairly young group in our 20s, 30s, and then I went down to the weapons design group in 991, and 91 was interesting at that time because you couldn't go in the back area at all. That was secret. You didn't have any access to information that you didn't have a need to know. So
and what was in the back area?
That's where they stored the finished pits, ready for shipment to New Mexico or to northern Texas. I think that was still used for the final assembly, or I'm not sure if they came into being at that time or not. Pantex.
Right. It's in Amarillo.
Yes. And then I got tired of drawing circles at that time.
You were designing the
Yeah,
specs of
I wasn't
the-
designing them, I was just draftsman.
and so were they all different sizes?
Yeah. They, at that time, they were still basically spherical, and later got into the free forms. And Ed McNamara, you talked to, knew a lot more about that than I do. So anyway, after about a year and a half down there, I went back up to engineering and was promoted, and I'm not sure when we moved to off-site. They needed more office space up in Building 11, so they moved engineering and purchasing both down to 40th and Wadsworth. And we were there for 3 or 4 years, and maybe more. And that was very bad for engineering. If you had a dimension you wanted to check at the plant, it was going to take you a half a day to go out there on a shuttle bus and then go into the buildings and get your measurements and then come back. So I'm sure there were some times there when they checked measurements by phone with someone out there, or it wasn't good. And
this was, you were back in the engineering group, so now you're working on, again, on buildings and
yeah,
assembly lines.
buildings, plant engineering it was called.
Which is designing the lines and
Yeah.
manufacturing.
And I ended up doing a lot of design of the glove boxes, and I'm a reluctant expert on glove box design.
Interesting.
But and then over the years, we eventually moved to a different office space out a little bit nearer to the plant at, see where that would be, 83rd and Harlan, about the office building that purchasing and engineering again were together, which was a good thing, because we did a lot of specifications that the purchasing people had to buy things by. And at that time, I was still in charge of the, well, when we were at Wheat Ridge, I was in charge of the engineering design group for glove boxes and equipment that the people used making the weapons. And the glove box is an important thing, because if you don't do it right, the guy can't reach his tools in there and can't machine a part. And we worked very closely with people in the production groups to get them the proper equipment. Then when I went to the Harlan Street address, that isn't exactly the address, but I got in charge of the project engineering group. And project engineering handled the construction of any new buildings or building additions that we were doing, major equipment additions in existing buildings. And that was really interesting. And if it was a major building addition, we didn't have the personnel to do that. So that was farmed out by the Atomic Energy Commission, DOE, to a company that did have the expertise and the personnel to do that. So project engineering was in charge of seeing that the necessary people at Rocky Flats were able to review all of the drawings to see that they were what they wanted, to see that the item was going to be designed the way they wanted it. We would bring up any changes that we knew had to be, because the people that were designing it weren't working with plutonium, and things like glove boxes we designed because couldn't take a chance on that being wrong.
Did you have to, you said that the contractors didn't work with plutonium, so did you have to change room configurations or anything like that in order to change the way the building was built because of plutonium?
Yeah, and all of the buildings were designed for a primary containment area. Like Building 76 had a main production area, and then airlocks at 2 or 3 doors into that back area that were from a cold area, and you had to go through there, and that would keep the air from flowing out of the area, and the production area was kept under negative pressure compared to the outer office area, so that you could work in the production building and never have any touch with plutonium or inhaling it.
How did they create the negative pressure?
How do they create the negative? By controlling the airflow, they would have supply air coming in from outside air, and it would be filtered through HEPA filters, absolute filters, and then go into the outside, the cold area, and also go into the other area, and then the exhaust fans would be controlled on the pressure. The cold area would be negative to the other area, would be positive to the production area, so that any airflow out of there would go up into the fan system or into the production area, so that the flow was from the cold area into the production area.
So was the flow created, was it all through fans?
Through fans,
in, or
yes.
Was it also like with the building construction?
Yeah.
Was one area higher or lower than the other?
Yeah, well, one higher in pressure than the other.
And you created that higher pressure only through fans? And
Through fans, and that pressure differential was also in effect with the production area. The glove boxes in that area were at a negative pressure to the room. So, and if that negative pressure got to be a little much, you'd see gloves standing out like that into a glove box.
So basically, there's just let's say we're in the work area and you're in the glove box area. There's just air just sucking.
Yeah.
In direction.
Yeah. So, and that was very good when we got into after the 1969 fire. To recover from that, they inerted a lot of glove boxes that had been just normal air. Back in the old days, when they machined plutonium, it was kind of pretty to watch, because you'd see fire rolling off of the tool bit, or a hot chip, not fire, but see them coming off glowing, because you're machining the plutonium and creating a little heat on a metal that already generates its own heat. And so every once in a while, the guys would have a fire in their batch of chips there, and they automatically just dump some powder on it that stops the fire. But they lived with it. They thought it was just a fact of life. Well, and that's the plutonium getting hot was what caused the '69 fire, of course. They had a too much, they had about 4-inch layer of Benelex all the way around it to keep it shielded radiation-wise. Well, that shielding also contained the heat, and they've in the after in the review of after the fire, and a large charcoal fire. By the time they realized they were on fire, 4 inches of Benelex burns like charcoal. So we no longer designed putting Benelex inside the building or inside the glove box, and we changed a lot of our design because of that. But I was going to say the negative pressure made it easy to inert the glove boxes with pure nitrogen after the fire. So the later machining there was always in an inert atmosphere. And
So before that, it had been oxygen?
it was just normal air, yeah.
And then after the fire, they started blowing
Yeah,
nitrogen in there?
it was down to, about 1% oxygen or less. So anyway, the project engineering group that I supervised handled buying new machine tools, new major equipment. One of the things that we did, one of the things that I did before I got to be a manager was buy machine tools. And they'd buy these machine tools that were $120,000 a piece. And you can imagine the competition for that was quite a bit. So we dealt a lot with a company in Detroit. Anyway, they made all of the machine tools that we had in Building 76 when they went to high tolerance, tolerances in the millionths of an inch. And I can't remember the name of that outfit right now, but they were the ones that invented the milk cartons that we use now.
Oh, really?
They made the machines that did that. But they're fine manufacturer, and we worked with them closely because the machine had to be enclosed in a glove box. So we told them what type of a sealing surface we wanted to build a glove box to enclose that machine completely. And that they had to work with the guys that had actually done machining and that were the manufacturing departments, production departments representative to buy the new machines. And we had new machines like that in Building 44 also for machining the uranium, and had at that time we didn't have any machining. I don't think we had any in Building 881. 881 was the enriched uranium, and it was never in glove boxes like the plutonium area. They had open-faced hoods there, and the engineering group worked all through the plant, of course. So we saw pretty much everything.
So, with the machines, when someone would, I guess, how would this machine, like from start to finish, someone would say, we need this machine, be it the AEC, they say, you need to produce this component or something, or how did the machine the concept get brought to you, and did you then work with the production people?
Well, it would have started with the design agencies at Albuquerque or at or at the facility in, you can see I've not been thinking about this much, but the facility near San Francisco, Livermore, and what's the one in Albuquerque?
Sandia Labs?
No,
Or Los Alamos.
Los Alamos. They had design engineers that would work and come up with what they needed physically. And they would, I think, give us some rough ideas of what they wanted finally, and then our production engineers would work with the design agencies to see what tolerances we needed, and they would tell us the basic shape that we would need, and then the production design group would make the final drawings, and that would get to the production people, and they'd said, we're going to need a new machine to do this. And of course, they're working in advance of the need, because it's going to take a year to order these machines, probably. So they would decide what operations the machine has to do, and then they'd give that to a production company or a machine shop, and they would do what they could do with other machines. They were into all computer controls on the machining, and at that time the people for the machine companies said we would prefer that you didn't have a good machinist working this because he's going to be trying to outthink the computer. So we did have some darn good machinists out there, though, working in our precision shop. We also bought machines that were about 10 times better on accuracy for our precision shop, because they had to design the tools that would hold these parts without hurting them. And so they did some fantastic work in that precision shop. I don't know where those machines have gone, but $1 million worth of equipment. And that was in Building 44. Anyway, I got into doing project engineering. I wasn't supervising project engineering when I was doing this, but after the 69 fire, we assigned a project engineer to handle all of the changes that were going to be done to recover Building 776, clean it up, and put it back in production. And 707 building was just about to come online at that time, I believe, and they used it as it was for a while, but after the 69 fire, one of the things we did was decide we had to have an inert atmosphere in there. So I had the job of making a nitrogen plant that would provide compressed nitrogen gas. They'd make it liquid first and then expand it to gas and pump it through pipelines that we built to Building 777, 76. It was actually to 776 and to 707, and a branch going down to 71 building to inert some of their lines down there. And that took, a year and a half anyway. Had to build a whole new nitrogen facility up by the warehouse building near 551. And that plant was operated by Air Products Company that provided the plant. They built the plant, so I was a project engineer overseeing, being an intermediary between Rocky Flats and Air Products. So, and you got me started talking here.
That's the idea.
Anyway, the research group at Rocky Flats, under working with the production guy that was project manager on that. He was the project manager, I was a project engineer. He was Ken Calkins, and had come up through building 771 and new 76 building also. And he worked with the user and with the people doing research. And they did a lot of research in building 79 on how low a nitrogen atmosphere we needed, what percent nitrogen, and what sort of leakage we would have into the glove boxes that would mess up the atmosphere. So rather than make twice the size of the nitrogen plant, we caulked up all the windows and made sure that our window design was more leak-proof. Went from our bolt spacing on the glove box windows was about three inches. We went down to 2-inch spacing on so that the gasket was clamped more places along there. And they made very sure that everything was leak tight when they made these glove boxes. So, which was good too for health physics people, keeping people healthy. Although I don't think that there was much leakage ever out of those boxes. They always kept them pretty high. You had they tried to keep them about 7/10 of an inch negative pressure, I think, in the glove box. And if you went up to 1 inch, your gloves were out like that, and they couldn't work in them very well. So it's a trade-off. You don't want too much, and you can't have too little. So we knew what the leakage would be at about 5/10 of an inch negative pressure. We knew what it would be at 7/10. We knew what at 1 inch in negative pressure. So they did a lot of research, and they produced that for all of the atomic energy groups. We were the first ones that had gone to a nitrogen atmosphere. And so.
She's asking why nitrogen.
The what?
She was asking you why nitrogen.
Oh, nitrogen is the cheapest inert gas you can find, because we got 80% of it in the air. And so the nitrogen plant on site sucked air in and dumped air out that was high in oxygen. So
And the reason you didn't want oxygen was because
oxygen supports fire, supports flame.
When it's exposed to oxygen.
Yeah. Yeah. It's yeah, you need fuel and oxygen to have, and heat to have a fire. So we removed oxygen. And I don't think they had any fires in their machining operations after that. And as far as I know, they didn't have any problems with excess nitrogen affecting the metal. So it worked out very well. And as far as the cost of that nitrogen, I don't think it added to their machining costs very much at all. So, and about then I was given another project back in 1970, late 1970, they started a project. The people at Sandia base were in charge of security for all DOE facilities, and they recommended that we completely isolate all production operations. So they came up with that they had built a facility down at the Pantex area with a 100-foot wide separated, no personnel allowed in that area, and about four different alarm systems in that no man's zone, and about 12-foot high chain link fences with barbed wire, concertina wire at the top, and 100 feet between fences, and then in between you had a layer of concertina wire about 5 high, and there was concertina wire at the bottom of each fence so that no person could get in there. But we found out that raccoons going to a garbage dump inside could climb up that fence and go over and not even pause. And the guards that were watching the TV cameras told us that, because we had TV cameras it was divided into zones about 50 feet long, and they had cameras in there and alarm systems for that zone, and then every zone on around the thing. And so that was an interesting project, and I had to design or make the report that told the Department of Energy how much money we wanted to do that.
To keep the raccoons out?
Pardon?
To keep the raccoons out, or
just
in general?
We couldn't keep the raccoons out, but it was to keep the personnel out, and it did a good job of that.
And that was just for the hot area? Is that right?
Yeah, but it incorporated Building 91, Building 771, Building 371, Building 559, 707, 776, 707, 77, 779, every building that handled plutonium.
Or uranium? Or?
Not uranium. We didn't protect the area around Building 44 or Building 81. So just the north side of the plant. And so when we did that, the design people that did that, we had a group of engineers come up to us from Dow in Houston to help us with the everything to do with that. More project engineers to help us with that, and then we had designers out in we hired a firm to do that. Can't remember for the life of me what the name of that firm was, but it was neat because I had a project engineer with me from Houston that was helping me, and he was in on things pretty much as I was. And the reason that they did the Houston bit was Dow Chemical wanted to get some more of their people experienced with plutonium and so forth. So we got help from from Houston whether we wanted it or not. So that's just personal. Anyway, it worked out real well because in 1971 in September I had a auto accident and was laid up for 12 weeks, and during that time the engineer from Houston helped a lot. And I remember he wasn't anything on glove boxes, and or one of the things we were doing recovering from the 1969 fire was adding some more plenums in building 707, the new building.
Plenums is filter?
have the filters, have a row of 4 filters completely separated, and the air goes through there. And basically they'd have to replace the first filter more often than they would the second, third, and fourth stage. And you could stand behind that 4-stage filter and breathe the air and be all right. No one did, but but the tests we ran said it was pure and ready to be discharged to the atmosphere.
So had you added an extra set or 2 of filters?
One of the things they found out, we had always had 4 stages of filters, but in the 76 building fire actually got into some of those plenums, and if it went through that first stage, the second stage was right behind it, separated by maybe 6 inches. And so they lose 2 stages. And so as a result of the 69 fire, and I was in on this too, that they changed the whole design standards for designing exhaust filter plenums. They had to be separated by 6 feet between each stage, and sometimes you couldn't make that much distance, but between 4 and 6 feet you had to have clear there. And they had to have a spray system in front of the first stage filters that would actually spray a mist of water on the whole thing. And on the inlet to the plenum, you had a pre-filter system there that would catch any particles or flame, and they were metal filters. And in that chamber you had even more sprays, so it would reduce the temperature, and hopefully the sprays in the on the filter's face wouldn't actually have to come on. So that was a big change on the design of filter plenums, where you'd had to take about twice as much space for them.
So did you have to go retrofit that system into all the old buildings as well?
Yes. And that was a problem on retrofitting them into old buildings, because they're designed to take that much space, and you ended up having to move some things around, and all the time still keep old filter plenums working and keep production going on. Just like highway design, you got to keep the traffic moving. And what else? Anyways, going back to that protection zone with all of the fences and new guard posts, and everyone had to go through the guard post away from the job, and they used to park right next to the building. Incidentally, parking. When we first went out there in 55, I started, you couldn't park on site at all. The security said you have to have a queue clearance to come on site. So they had interview rooms and so forth out in the lobby of this one building, and the fence closed in that building so that they had a guard inside in that lobby area, and you had to go through him to get inside. And everyone clocked in a clock alley in Building 11, and you had a parking lot at Building 11 and a parking lot at Building 81, and that was it. And they had buses to run you from 81 to various production buildings. But in Building 11, you just walked through and went to Building 44, would be the furthest place. So a lot more security than what we had. Whether it was as good, whether they checked them out as much as the security finally, I don't know. they didn't have the radiation detectors that we did later, and you had to go through a radiation detector coming off of the plant, and went through it on the way in too, but and that slowed them down a little bit. But security was always very, very high there. Anyway, after I got that project for the design of the security zone, and had worked on the recovery of Building 69 after the 1969 fire, recovery of those buildings, I was made project engineering manager and was that for a few years. And then 13 years before I retired, I became a shift superintendent. And I had been an alternate shift superintendent, called that an ass, because you weren't paid any extra for that. And the shift superintendents worked 3 shifts a day, 7 days a week. And so they would give you comp time off. Well, if you got an engineering job and you got a project, you're not going to get any comp time off. So the ass was very applicable. And that was back in 1983, I think it was, or 82. I went to be a shift superintendent, and that was 3 shifts a day, round the clock.
And so what did you do as
shift superintendents were in charge of the plant nominally during the off-shift hours while top management was not there. But they knew who to call if there was something that needed management decision, or they knew who to call if they had an emergency. So it was a great job. You got to work closely with the security people and closely with the fire department. We were on first names with them, and they called us the emergency director in addition to shift superintendent. And the emergency director, we followed the ambulances and the fire department wherever they went, and were there if they went into a plutonium building. Maybe they didn't know what hazards they would be encountering there. This came about, the shift superintendents were first put in after the 1969 fire, because they found out that happened on Mother's Day, and a lot of people off on vacation or whatever, and they ended up not getting the help that they needed for a while. So the fire department and security people were there and taking the load. And so I finished out my time there as shift superintendent. And that was a great way to prepare you for retirement, because we worked 3-day weeks, and you'd work 12-hour shifts. And in the end, we first started out working 8-hour shifts, and that got to be quite a scheduling problem and so forth. And then the 12-hour days worked out real well. And I couldn't tell you what that schedule was like anymore. It got so complicated. But it was a good way to prepare. But it taught you how to sleep during the daytime too.
So you were working nights?
Yeah. We alternated shift. Shift superintendents would work night or day. We'd alternate, so that you pretty well got to meet everyone around the plant. That if the night shift guy said there was a problem down in this one area and he had a tough time finding what he needed there, you'd go talk to the guy that's in charge of that, And we were a good service for the plant. If you can call a guy at 2 in the morning and wake him up and he's not ticked at you, you know you must be doing something that he appreciates.
So as shift superintendent, you had an office in the 111 building, and you would just, as calls came in, you'd go to different buildings?
Yeah, our office was in 111 at first, up right next to the security director's office, Ed Young. Have you interviewed Ed Young? He'd be a fountain of information. He's down in Albuquerque. Not Albuquerque, but Phoenix, Mesa, Arizona. And we were up there in a just small office space, about 20 by 20. And the instrumentation, the television, watching various areas was not there. So eventually, when they built a new security building, 115, not DOE building, 115, we got a large area there that was used, had a meeting room for emergency personnel to come in and meet and talk about what each one was doing. Their manager would be there and their personnel would be in the field. We had all sorts of communication set up so that the shift superintendent saw all areas of the plant on his TV screen. We had TV from the PSZ, the perimeter security zone that I mentioned before. So we could go through those cameras that security saw also. So we pretty much had anything at hand that security had as far as information. Mm-hmm. We didn't act on it like they did, of course, but after 13 years there, I retired. I was almost 66. I got early retirement benefit. I thought that was pretty nice. Of course, Uncle Sam took most of it.
What year was this?
It was 1995.
Oh.
In July of 1995. So I retired the day before Kaiser Hill took over.
Oh.
Kaiser Hill, my only involvement with them is getting retirement checks from them. That's nice.
Well, we have a few minutes before you change tapes, so
Okay.
I guess I'll just run through some of these questions sort of in order.
Okay.
So I'm wondering, when you first learned about Rocky Flats and interviewed for the job, did you know what they did then?
No. When they interviewed at Edgewood, Maryland, they told me it was a government contractor and that Dow was the prime contractor for the AEC at that time. And at that time, Dow did food service, did security, everything to run that plant was Dow Chemical Company. And Dow was an excellent company to work for. They treated their personnel very well. They had a real nice safety program, constantly reminding you of safety and so forth. And about every 6 months to a year, we'd have a safety awards banquet down at the Aviation Club, where people could dance and so forth, and have a good meal and socialize with everyone in their safety group. So it was really a nice thing for all the plant. And Dow then operated it until 1975. And I got a 20-year badge from Dow in February of that year. And Rockwell International took over in July. I got a 20-year badge from them the day after they took over. So I had 40 years.
Yeah. Just like that.
And Rockwell was good to work for, but not as personally involved with their personnel. They weren't a people company as much as Dow had been. And then 95, we got, well, Rockwell gave it up because they were having to take the whole brunt of the blame for the 69 fire, well, not for the 69 fire. Dow got ticked off with the DOE for that. Dow bowed out, you know. In fact, their last year's operating fee for operating the plant, they told the DOE, we're just going to pass that out to our people. So to let them know that what you're paying us isn't all that much. And DOE, AEC at that time, didn't take any of the blame for what happened at the plant. And they should have.
Why?
They were, at that time, very involved on any decision that was made at Rocky Flats. Any new production, like beryllium, they told us to do it. And the beryllium was really something. In fact, our director at that time of health sciences, Dr. Chapman, told us, he says, you think plutonium is difficult to work with, just wait till you try beryllium. And so we started out in engineering realizing that that was a mess to work with. And I got in on the design of the beryllium shop that we had first. So that was interesting. And they had enough vacuum on those machining setups that guys were complaining every once in a while they'd drop a tool and it'd go into the air drop, air vent.
So you guys knew what you were dealing with beryllium.
Yes.
From the beginning.
Yeah.
And did you get the sense that
I don't think that at that time they didn't really realize how bad beryliosis was. Dr. Chapman, I know, wrote a letter to management giving his recommendation that we not do that beryllium, but he didn't win.
Did you get the sense that the AEC didn't really know what they were? You know, they just ordered you to do things. They didn't realize how hard these materials were.
I think they were trying, but they didn't know everything that they could have known, and there was a need to use beryllium in the weapons. So they had a lot of push to get us into production on beryllium. And so we were machining the heaviest metal and we machined the lightest metal. Interesting plant.
Okay, I'm going to stop you because we're at an hour here.